Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily lead code problem, and the problem's name is evaluate Boolean binary tree. So you are given the root of a full binary tree. Full binary tree is a binary tree in which each node will have either 0 children or 2 children. So none of them will have only one children. Okay, and leaf nodes in this particular full binary tree will have value 0 or 1, 0 representing false and 1 representing true. Okay, and non-leaf nodes will have two values, one of two values, 2 or 3. 2 means that it is representing a or operation in sense that you have to or the values of its children that you are getting from its children. Okay, so this is what two means, and means you have to end the values that you are getting from its children. Okay, so if we take this particular example 1, and take it to the board, so you will observe that here the value must have been 2. Okay, and these childrens of these two were returning true and false. Okay, so we did a or of true and false, and it resulted into true. Okay, and similarly if you take this one, it must have been 3 representing and, so its children returned false and true. When you did a when you will do a end operation on these two, it will result into false. Okay, so this is in general what we have to do in the binary tree, and we have to return the value that will be present, either it will be true or false on the root node. Okay, a full binary tree is a binary tree. Each node has 0 or two children. Okay, as I already told you. Okay, and you have to return the boolean result evaluating the root. So it's very intuitive, and it's very easy to observe that we are somehow, going in bottom up manner. Bottom up manner in the sense that we are first evaluating the leaf nodes. Okay, level by level you can say, or first evaluating leaf nodes of the current branch and then the upper node. Okay, it is proceeding like this. Okay, so a recursion is very recursive approach is very intuitive and easy to come up with. You can just run a simple DFS, depth first search. Those of you who are hearing this term for the very first time or do not know what depth first search is, depth first search is nothing but you start from somewhere, then you have a set of choices. Let's say I pick this one, and then I go down this path, then again we will have some set of choices. Let's say after picking certain choices, we end up somehow here. Okay, and after that there is no further way to go. Okay, it means that there is a dead end. Then what we will do, we will go one step backward and check whether are there any other choices to explore. Yeah, if there are some choices, then we will certainly take them and go till the very end and the same thing. Okay, over and over. So this is what depth first search is. It means exploring the current path till the very depth. Okay, and then coming back and one step back at a time, and then exploring other possible paths. Okay, So this is what depth first search in nutshell. I will try to find an article on this explaining what DFS is, how to use it, when to use it, and similar things. Okay, so you can definitely explore that article if you are not familiar with DFS. Now coming back to our problem statement, we will apply a simple DFS. So it will be easier for me and it will be a little convenient and time saving for you also if I just take the code and make you understand how things are working out. So just a second. I think I found the code that I earlier coded. So this is the code. Okay. So let's take it to the board. This is the optimized version of the code. So I am trying to explain you optimized version directly. Although the overall worst case time complexity won't be affected by this optimized version, but I will explain you this only. So let's begin. So first of all, what you will be doing, and for the sake of clarity, let's copy this image also. Okay. How to copy it? I think we can take it from here. Yeah, now it's fine, and let's reduce its size. Yeah, it should be visible enough now. So what we will be doing, starting from the very root of the binary tree, you will go down till you are not able to go down any further or you reach a leaf node. So this is what the condition looks like for leaf node. The left and right child of this node will be null. So you know, in that case you will be returning whatever this leaf node is holding. Okay, so if 0, it will be converted to false by this typecast, or I think in C++ it should not be required. We will try that out anyways. So this will 0 will result into false and 1 will result into true. Okay, so this is what this statement is doing till here. And then for the current, if that is not the thing, that you are not at a leaf node, it means that you must be at some 2 or 3 value node. So if current roots value, it means current nodes value is 2, that means you have to do or operation, and if it's the other way around, it means it's 3, so you have to do the AND operation. Okay, so you will just recurse for the left subtree first. This is a little optimization that we are doing. We are not evaluating the left and right subtrees both, because if the left value is already true, then there is no need to evaluate the right value. Why so? Because whatever you take of uh or of true with, I mean, if let's say I take true and false, and even if I take true and true, then no matter what this second term is, we will always get true if the operation is or operation. Okay, so that's why if the left value is giving you true, I mean left recursive subcall, recursive call, then it is no need to check for the right subtree. Okay, you will simply return true. If it's not that case, then you should evaluate right subtree. Okay, and in that case you will return whatever the right is returning you. Okay, and it means that if we are cross this condition, it means that left is already false. If right is true, then okay, that's great, we will be returning true. If right is also false, then we will be returning false. So the result will depend entirely on right subtree call, provided that left value is false. Okay, and similarly similar case will be for AND operation, except one little change, that if left value is false, because of the properties of AND, that whatever you do of AND with AND of false with, so it will result into false. So let's say I first one is false, then no matter what it is, the second operation operator, you can say, it will always result into false. Whether you can take false and true or false and false, both of them will result into false. Okay, so both of these results into false. So in that case you will return false. If it is not that case, then your value is dependent on right, because it means that if you are past this case, it means that left value is returning you true. Okay, so this is will what the code is. And I think you must have guessed what will be the complexities in DFS, since you know, overall, if the tree is not balanced and it is a skewed binary tree. Okay, so in that case, in worst case, theoretically it can be order of n, where n is the number of nodes. Okay, and same will be the case for space complexity. I mean, because of recursion call stack, worst case theoretically can be order of n, though it will be less than that. Okay, uh, on average, but theoretically you can say that it will be that. Okay, and in worst case, we are talking, so these will be the complexities. And if you still have any doubts or any queries in general, then you may ask them in the comment section. I hope this solution walkthrough and this tutorial added some value to your journey of owning your DSA skills. And until then, keep solving problems and keep practicing. I will see you in the next video. Thank you for watching.